So welcome students. Today we are going on with the next problem. The problem is example number 1.3. It is available in your book at page number 7. Come on, go through the problem. Two small sized, identical, equally charged spheres, each having a mass 1 milligram, and are hanging in equilibrium as shown in the figure. The length of each string is 10 centimeter and the angle theta, which is equal to 7 degree, made with the vertical. Calculate the magnitude of the charge in each sphere, and given, take the acceleration due to gravity g as 10 meter per second square. So, in order to study about the solution, first of all, let us consider the data that are being given. The data is given, you see, let us take the length of the string as L, which is equal to 10 centimeter, 10 into 10 power minus 2 meter. Then mass they have given, let us consider it as M. Mass is 1 milligram. So 1 milligram, when it is converted into gram, it is 10 power minus 3 gram. But the standard unit is kilogram. If you want to convert gram into kilogram, then it is 10 power minus 6 kilogram. So mass is equal to 10 power minus 6 kilogram. The angle made by the string with the vertical is considered to be 7 degree. Okay, these three are the given quantities, and the asked is what is the amount of charge Q available. So let us move on to the next page. I am dealing with the diagram again. See, initially, if you are considering this is the rigid support, from this the two bobs are following or hanging down. If these two spheres are neutral, if you are considering the spheres as neutral, if you are considering the spheres as neutral, then the angle of deflection theta equal to 0. Then let us consider this as the first diagram. Let us go for the second diagram. Since, see, we can consider here, since the spheres are, since the spheres are equally charged, they get repelled, so that angle made with the vertical is theta, which is 7 degree. This is the vertical line. Due to the charges available, the two spheres are repelled away, so that at one end you are having a charge plus Q, and at the other end you are having the other charge. Here you see the angle described, theta equal to 7 degree. This is the length of the string, considered to be 10 centimeter. The distance between the two charges, let us consider it as R. The distance between one of the sphere to the center, let us take it out as A. So on comparing, we can say R is equal to 2A. See, first of all, I am calculating the value of A from which R can be calculated. So how I can able to calculate A? You consider this triangle, right angle triangle. Let us mark this as O, this as A, this as C. So consider an right angle triangle OAC. In this right angle triangle OAC, you calculate sin theta. Sin theta is opposite side by hypotenuse. Opposites is A divided by hypotenuse is L. So I can write it out as sin theta equal to A by L. On simplifying, I can write A equal to L sin theta. Now from this 2A equal to 2L into sin theta, which is equal to R, the distance between the two charged bodies. Let us have it inside an rectangular box. Now, let us analyze this in order to calculate. So, you draw a free body diagram. Draw, in your 11th standard, you might have studied this. Draw a free body diagram or a figure. When you are considering the free body diagram for any one of the charge, for any one of the charge or any one sphere. Let us take this sphere at A. See, you are having the charge Q here. Now the string is along this direction from the rigid support. This is the vertical line. The angle described is theta. Now let us consider what are the forces that is available here. First of all, the gravitational force acting vertically downwards. This gravitational force acting vertically downwards is m into g. Since you are having two spheres which are repelling each other because of same nature, the electrostatic force is acting in this direction. Let us write it out as Fe. Now, along the string, you will be having the tension acting it, because the tension acting in this direction is due to the repulsive force as well as the gravitational force acting on this charge or acting on this sphere. So in order to proceed with this, what we are doing is you resolve the tension T. You resolve the tension T into two perpendicular components. You have studied in vectors how to separate a single vector into components like that, into two perpendicular components. See, when I am resolving this, I can resolve it into two. one as the horizontal component, and another one as the vertical component. See, if this angle is theta, then this angle is also considered to be theta. So I am drawing this diagram again here. You see, you are having the charge plus Q. The tension is acting along this direction. That tension is resolved into two components, one along the horizontal and another one along what? Another one along the vertical. This angle is theta because from the rigid support you are having this angle also as theta. Alternate angles are equal. Now you see, for this theta, the vertical component is the adjacent side. So the vertical component is t cos theta. The horizontal component is the opposite side. So the horizontal component can be written as t sin theta. Now let us consider the other two components. See, the tension T resolved into two components, two perpendicular components, one along the horizontal, another one along the vertical. The vertical component is adjacent to theta, so it is t cos theta, adjacent side. Horizontal component is opposite to that of theta, so I am writing it as sine. Opposite side is sine, so I am writing it as t sin theta. But from this figure, I can write, see, along this direction, I am having the electrostatic force Fe, and vertically downwards, I am having the force mg. Now, let us consider the horizontal forces as well as the vertical forces. So, I am considering first of all the horizontal forces. When I am considering this horizontal forces, you see, in x direction, the net force is 0. The net force is 0 because after repulsion, the charged body is at rest. So, net force is 0 means acceleration on the sphere. Acceleration on the sphere is also equal to 0. So, the next component, I will be going to the next page. You see, when I am considering the next page, see, I am taking this in x direction, okay, in x direction, let us consider, in x direction, on the left hand side, you are having Fe, on the right hand side, the force that is attracting towards, that is t sin theta. So, in the x direction, since acceleration is equal to 0, it is not distance, okay, let us write here, acceleration is 0 using Newton's second law, we can state that F equal to ma. So here the force is the total force, which is equal to m into a, but a is considered to be 0, so total force is equal to 0. See, let us recall, along the x direction, you are having the charge here means, here you are having t sin theta, and here you are having Fe. So, I am taking this by considering the free body diagram. So, on the right hand side, so I am writing it as t sin theta along the x-axis towards right. So, I cap, vector notation. minus, because on this side Fe is along the negative x-axis, so minus of Fe I cap, or if I am putting it plus here, I have to put minus I cap here, which is equal to total for 0. If I am rewriting this t into sin theta I cap is equal to, or I can write is minus, okay, I can write like this, minus see some problem. So sin theta I cap, then I will be getting, see, plus here minus, so minus f of e I cap equal to 0. Take it to the right side, you can write t sin theta is equal to, I am considering only the magnitude, which is equal to f of e. Take this as equation number 1. See, these two steps are not necessary. We can directly write that T sin theta balances the electrostatic force. But it is in your book, they have given it out in vector notation, and so I have dealt with that. Otherwise, you can directly write what? You can directly write this T sin theta equal to Fe. Okay, let us consider this one. Then let us go for the next. Here we have considered the x direction. Similarly, let us take along y direction or along the vertical direction. So let us consider along y direction. In the y direction, in the upward direction, you are having t cos theta, and in the downward direction, you are having m into g. Here also total force is 0. So I can write t cos theta, upward direction is taken positive, since it is along the y direction, j cap plus m into g, downward direction minus j cap is again equal to 0. This I can write t cos theta j cap minus of plus minus of m into g, j cap equal to 0. See, when I am considering the magnitude alone, I can write t cos theta is equal to m into g. Take this as equation number 2. Similarly, as per the last one, these two steps are not necessary, but according to your book, let us write it out. So, let us take this as equation number 2. Now, you consider equation 1 divided by equation 2. So let us separate it out, and you just take like this. See, equation 1 divided by equation 2. What is equation 1? Equation 1 is t sin theta divided by, left hand side of equation 2 is t cos theta equal to, here you can write f of e divided by m into g. So I am taking this as equation number 3. Here t and t will get cancelled. So I can write sin theta by cos theta can be written as tan theta, which is equal to Fe divided by mg. Take this as equation number 4. Now, what is Fe? We know that Fe is the electrostatic force. But what is the value of Fe? We know the value of Fe is K into Q1 into Q2 divided by R square. Here we know Q1 and Q2. Here we have studied, isn't it? Q1 is equal to Q2 is equal to Q. What is K? K is 1 by 4 pi epsilon 0. That is 9 into 10 to the power of 9. then that is Newton meter square per coulomb square. Then what is the value of R? Already we have calculated in the previous page as R is equal to 2A, that is equal to 2 into L sin theta. You just take the pages that we have done before and note it out how you can able to get that value of R. So these are the quantities that has to be substituted in this equation. So either you substitute this and write it here, or substitute the value of Fe and write this. That we shall do. See, I am writing tan theta equal to, instead of Fe, K, then I can write Q1 into Q2 as Q square divided by, instead of R square, I am writing 2A the whole square, and here you are having M into G is equal to. So I think you are clear. So this gives the value of what? This gives the value of K, sorry, Fe, K, Q square, instead of R 2A the whole square. Now substitute, what is the value of K? The value of K is 9 into 10 to the power of 9. So I am substituting 9 into 10 to the power of 9 into Q square divided by, what is 2A? 2A is 2L sin theta. So 2L into sin, instead of theta you will get 7 the whole square multiplied with M, it is 10 to the power of minus 6, multiplied it with what? Multiplied it with G. G is another 10. Clear? Now again, from this you substitute for Q square. Q square is equal to, make a cross multiplication, you are getting tan theta multiplied with, take this to the numerator, 2L sin 7 the whole square multiplied with, on simplification you can write it out as 10 to the power of minus, or you write 10 to the power of minus 5 divided by, whole divided by, take this here, you will be getting 9. That's all, isn't it? So taking this to here, here you are getting 10 to the power of 9. The 10 to the power of 9, and I am taking here, I can write this as 10 to the power of minus 9. I think you are very clear. Now you simplify and get the answer. So in order to simplify, you calculate the value of what? You calculate the value of Q. What is the value of Q now? From Q square, you have to calculate the value of Q. See, Q square, just you see the previous page, what is Q square? Q square is, you are getting it as tan theta multiplied with 2L sin 7 or sin 7 the whole square multiplied it with 10 to the power of minus 5 into 10 to the power of minus 9 whole divided by, you will be getting it as 9. Am I correct? Now you simplify and get the answer. You simplify and get the answer, that will be the answer. So what is the value of Q? Q equal to, on taking root, this will become 2L sin 7 multiplied with, here it is 10 to the power of minus 14. So on taking the root, you will be getting 10 to the power of minus 7 whole divided by, then 9. For 9, you consider the root, it is 3 into root of tan theta. You can write it out as tan 7. You simplify and get the answer. That is the homework for you. So just a simplification, you will be getting the answer in terms of coulomb. See, I have done this. If you want, you can still you can state 2 into what is L? L I can write 10 centimeters, 10 into 10 power minus 2 into, you take the logarithm book and put sine 7 multiplied with 10 to the power of minus 7 into root of tan 7 whole divided by 3. See, in your book they have made a mistake. That is, instead of here, when you are considering milligram, they have tried to convert it into kilogram, but they have given it out in terms of 10 to the power of minus 3 gram. And they have taken it the length in centimeter, but here I have converted it into standard units called to be SI units. So what you have to do or how you simplify, just I will be giving an explanation alone. You simplify and get the answer. Okay, you write logarithms. For writing the logarithms, you take the numerator. First of all, you consider the numerator, the value for logarithm for 2. Okay, log for 2. Log for 2 is 0.3010. Then you consider log 10. What is log 10? Log 10 is 1 point. Log 10 is, you will be getting it as 1.0000. Then log of 10 power minus 2, you can write it out as 2 bar 0.0000. Then you consider log of sine 7. You take your Clerk's table and go logarithmic signs. In logarithmic signs, you get the value of sine 7 and put it here. You will be getting 1 bar point some value, check it out. And then you go for logarithm of 10 to the power of minus 7, you will be getting 7 bar 0.0000. Then tan 7, you calculate it separately. See, tan 7, again you take logarithmic tangents. In the Clerk's table, you go for the table called to be logarithmic tangents and calculate the value of tan 7 degree. Again, you will be getting a value, take that value, divide that value by 2 because it is considered to be root. Divide that value by 2 and get the answer. Now, all this plus this value gives you numerator. Adding all, okay, adding all, you get the numerator. Then you consider the denominator. What is denominator? 3. Denominator is 0.4771. That is log of 3 is this value. After that you calculate numerator minus denominator. After calculating this, get anti-log, you will get the answer. Check it out whether you are getting the answer as it is given in your book. See, in your book they have kept it in 10 centimeters as well as in gram instead of kilogram. But it is not a fair part. While doing the problems, first of all, we have to convert all the given data into SI units. After that only we have to proceed. So, done it. Your work is just to simplify. You simplify it using logarithms because you won't be supplied with calculators in your examination. So you do it with logarithms. After doing it with the logarithms, if you want, you check your answer with the help of the calculators. Okay, clear? Very good. Go through the problem again and try to solve it out in a single page so that you can able to see the previously what you have worked out. Thank you. All the best. Let us see in our next video.